Hello and welcome to my presentation on my CyberEPQ project entitled What is Cryptography and How is it used within modern information security systems? My project aims were to research cryptography, find out its uses, determine its benefits, determine its downsides, collate my research, and produce a report. My work process began with research. I researched cryptography, its uses, its downsides, its upsides, and then I began to plan my report. I used Moscow analysis to bring a list of topics that I was considering writing about and make it a much more manageable size. I then looked at these topics that I decided to write about, looked for links between them, and used those links to influence the order that they appeared in my essay. I then wrote my report. Once I'd finished writing my report, I read it, and I realised there were things in there that I don't think should have been, and things that I wanted to add, and things that just didn't quite sit right and maybe needed rewording, so I rewrote it. And then I kept doing this until I was happy with my end result. So, moving on to my findings, what is cryptography? Cryptography comes from the Greek word for secret writing. The Oxford English Dictionary defines it as the art or practice of writing in code or cipher. And Microsoft has called it the cornerstone of the modern security technologies used to protect information and resources, which makes it a very high-profile topic in the current cybersecurity industry. There are two types of cryptography, symmetric and asymmetric. Symmetric cryptography is also known as secret key cryptography, and is what most people would probably define as traditional cryptography, as OWASP put it. This uses one key to both encrypt and decrypt data, and only this key is kept secret. The algorithm doesn't matter, the ciphertext doesn't matter, all that matters is that the key is kept secret. However, this does have the key exchange problem, which means in theory this system works, but in practice you need to have first exchanged a key with the person you are trying to communicate with, without anybody else being party to it. Asymmetric cryptography was developed to combat this problem. It's also known as public or private key cryptography, and was publicly proposed by Diffie and Hellman in 1977. I emphasize publicly there because it was in fact proposed several years earlier by James Ellis, who at the time was working covertly for GCHQ. So going back to why it's called public or private key cryptography, it's because two keys are used, a public key and a private key. Everything encrypted with the public key can be decrypted with the private key, and vice versa. So if people want to communicate with you, they send you the message encrypted with your public key, and you can decrypt it with your private key. And then you can reply to them by encrypting your message with their public key, and they can decrypt it with their private key. Only the private key is kept secret, which means the public key can be published anywhere, and that's what eliminates the key exchange problem. No key exchange problem. Benefits. So, cryptography provides several benefits, but the main ones are authentication, non-repudiation, integrity, and confidentiality. So, authentication is saying, I have the corresponding key to decrypt this message, therefore I am authorized to read it. Non-repudiation takes this a step further and says that if somebody has encrypted a message, then they cannot deny having sent that message. This is what asymmetric cryptography provides in applications such as digital signatures. Integrity is basically ensuring that data is what you expect it to be and hasn't changed. So if I sent you a message, you should be able to tell if somebody has got to that message between me sending it and you receiving it and changed it in any way. And confidentiality basically means providing security and stopping other people from being able to see what you have written without you wanting them to. So uses of cryptography. It's used in file encryption to encrypt files at rest, so on your hard disk, on your USB drive, etc. So you would require a password to be able to view or edit these files to stop anybody just looking at them. Then you have network encryption, which is encrypting data in transit. So that is, if I am sending something to you over a network, it would be encrypted so anybody listening in on the wire couldn't tell what it was. There is hashing, which basically produces a unique message digest for a message. So if I sent you a message and I sent you a hash, you would be able to hash that message and you would be able to compare the two hashes. And if they didn't match, then you know that the message has changed since I sent it to you. This is what the purpose of message authentication codes are for. Digital signatures take message authentication codes a step further by encrypting them with a private key. So you can then decrypt it with the person's public key, and if you don't get the same hash there as the hash of the document, then you know that either the document has been tampered with or the person who has sent you that document is not who you think they are. And then digital certificates are used to authenticate people over networks. They are usually used by secure web services such as online banking. They're what make that little green padlock icon appear in your browser when you're checking your balance online. And they basically go through a central trusted certificate authority to say, yes, this person is who they say they are, and I can prove that. I can say, yes, I know that this bank is this bank, so here's a certificate, and if you use the website that shows you the certificate, you know that this bank is who they say they are. So, project review. I thought that I had a well-structured plan of action. I knew exactly what I wanted to do, I knew exactly how to do it, and I knew when it had to be done by, with clear goals. So I set myself goals. I said I need this done by then, I need that done by then, and all the way up until the end. However, my time management could have been improved. I failed to account for unexpected problems, such as illness or work, and that led to me falling behind on my project. However, I do deem this project to have been an overall success, as I was able to conduct my research around my chosen topic, and I was able to produce a report